All right. Welcome. We have two more sessions for you this afternoon. I hope you stay for both of them. Our next session is entitled Serving Hosts at Scale, and it's being hosted by Jonathan Manuzak, CTO of CodeGuard at Sectigo. So please welcome for us Jonathan. Please bring Jonathan up. Jonathan.
Hey, good afternoon, everybody. My name is Jonathan Manuzak. I'm the CTO of CodeGuard. Has everybody here heard of CodeGuard? Show of hands. Okay, for those of you that didn't raise your hand, there's some people right here that would very much like to talk to you, so maybe see them after the session. So for everybody that doesn't know what CodeGuard is, we're known for our world-class backup. We serve hosting providers, web professionals, and even individual SMBs all over the world. We provide them with website and database backup, along with a variety of other things. CodeGuard, as a backup product, has often been called a time machine for your website. So I want to take you back in time a little bit, back to a long ago land of 2011. In 2011, in May, CodeGuard launched at TechCrunch Disrupt in New York City, and to great fanfare. We won the Audience Choice Award. It was a very successful launch. We were able to attract some early partners, and because of that, we started to really scale the product and scale the business. Here's what things looked like, excuse me, from 2012 through 2015 in terms of customer growth. And when we launched at TechCrunch Disrupt in 2011, we were running the CodeGuard service on a single dedicated server. We couldn't handle this on a single dedicated server. By September of 2011, we had moved to Amazon Web Services. And it was in these kind of early formative years that we developed our engineering processes. And I'll let you take a brief look at them. We really adhere to the Unix development philosophy. We like building small, composable tools. And if you've ever used the Linux command line, you've seen a lot of these tools, or you've seen tools that we've tried to model our service off of. You can take really small things and chain them together into something very powerful. We believe in the agile development philosophy, not just in that the agile Scrum kind of methodology, but in the sense of we always need to be taking in new information. We need to be learning. We need to be continually improving our product and our process. And it really takes discipline to be able to go from prototype to a mature, stable product. We really enjoy open source. We use a lot of open source technology to build the product. But when the open source technology isn't available, we have to evaluate whether we build or whether we buy something. We always prefer to buy it if possible so that we don't have to build it. We like to build the things that are just core to the CodeGuard business. Automation is huge. We've always been a very small, a very lean team, and we can't get bogged down doing things manually. We have to automate everything from the very beginning. Proactive error resolution is a core tenet of what we believe in because we have a daily website and database backup service. So we only have 24 hours to deliver on this commitment to our customers. So if we don't notice the errors early, if we don't correct them, if we don't stop our customers from being our beta testers, then we're going to fail in our commitment of performing these daily backups for customers. And continuous integration testing goes hand in hand with that. As the product matures, as the code base grows, we have to be confident that as we make changes over here, we're not breaking other things over here. And it's really this ethos that we developed that allowed us to grow like this in the early days, 2012 to 2015, and then continue growing beyond that to the end of 2018. And you can see here that at the end of 2018 and through today, we have more than 300,000 customers around the world. We have 1 million websites that we've backed up. We do 5 million backups a week. And through all of that, we have 1/2 of one engineer's time dedicated to doing customer support. So I want to take you through kind of more nuts and bolts of how we deliver the software, how we provide the service, and how we do it at this scale. And for us, it all starts with the code. We're a software as a service company. The software enables the service. So if you look in our GitHub account, you'll see we have 68 different repositories. And they're not all active. We certainly don't update them all every day or even every week. But this is a kind of example of our Unix development philosophy. We build small things, they're self-contained, and we can chain them together to build something really powerful. Again, according to GitHub, we have 12 different languages that we have checked in, and again, this is us choosing the right tool for the job. We love open source, we love Ruby, we love Go, but we also use things like C# to develop our Microsoft SQL backup technology. Moving a little bit more into the development process, we believe in containerization, and more than that, we believe in disposable containers. We use tools like Docker and Vagrant and VirtualBox to allow our developers to build things in an environment that nearly replicates our production systems. This allows them to build with confidence, it allows them to build quickly, and it allows them to jump into these 68 different repositories quickly. Automated testing has thankfully become more and more popular over the last several years. We use a wonderful tool called Semaphore to manage our automated testing. But one thing that we haven't seen done a lot that we really like is doing style consistency testing. It's important that as a code base grows, you have engineers coming in and out. We want to maintain a consistent style throughout our projects. And it's something that we can define and it can evolve over time, but it's important that we check as things go in that they are adhering to the quality standards that we have. Now, with all of this automated processes and things like that, we do have a manual step in there too in peer review. And we'll talk a little bit more about this in a second, but peer review is an important part because it allows for a conversation on the development team. It allows senior engineers to mentor junior engineers. It allows for people to learn new things. So that manual step, while not perfectly automated, is an important step in the process. So here's what things actually look like. A developer will check things into a feature branch. We go through our testing. It goes through peer review, through the GitHub pull request process. We'll do any kind of manual quality assurance that needs to happen. And then ultimately, it gets merged into the master branch. And then, when we're ready to deploy, onto production. So how do we actually take this code that we've developed and packaged up and tested from GitHub out to production? For our production branch, it's a one-click deploy, again, using this wonderful Semaphore tool. And if you're familiar with Jenkins or something like that, it's kind of similar. For staging, it's actually 0 clicks. Things that go into our staging branch automatically get deployed to our staging environments around the world for testing. Of course, it's all automated. And we use a blue-green deploy strategy, where we'll deploy all of the new code while keeping the old code running, and then slowly transition from one to the other. And this is what that looks like. We go from somebody clicking the deploy, a human saying, yes, I want to deploy our production systems. We launch a Linux base instance. We perform all the updates. We import that tested application code and any custom binaries that we've built from those other 67 GitHub repositories. Then we package up all of that as a machine image, and then we launch it to the various Amazon instances and regions. We have 2 types of instances that we talk about a lot. One is Spot, and one is kind of regular on-demand Amazon instances. We'll talk a little bit more about Spot later, but it is kind of a different process for pushing that image out to those instances. And then we have the health check. We want to make sure that these things that we've deployed are healthy, are functional, before they start accepting backup jobs, before they start accepting customer traffic. And once we have that confidence, then we start transitioning things, transitioning the traffic, transitioning the jobs, and then ultimately gracefully shutting down the old systems. So we did this deploy, we talked about the process, but where are we actually deploying? If you'd asked me 2 years ago, I would have said we're deploying in US East, Amazon's biggest, oldest availability zone. But today, we're deploying to 7 different regions around the globe. So we're deploying simultaneously with one click, 7 different regions all over the world. That seems like a lot of servers. If you're thinking that, you'd be absolutely correct. So how do we manage all this infrastructure, these different Amazon accounts and systems? And the answer is automation. We made the decision to manage the infrastructure as code. We don't need to have humans spending their valuable time in clicking buttons in the Amazon console or writing Amazon scripts when there are these wonderful open source tools like Terraform that we can use to build up our infrastructure. So we took the things that we had manually created in Amazon Web Services in US East over the course of 5 or 6 years and packaged them up in Terraform scripts. So not just the servers and the availability zones and the load balancers and things, but all the way down to alerts and metrics and monitoring and logging. These all get packaged up and deployed with the Terraform scripts. And what it means is that we can take our whole infrastructure, production-ready, scalable infrastructure, and deploy it in different Amazon regions very quickly. We take advantage of auto-scaling wherever we can. And we think that all of these servers should be treated as cattle and not pets. I don't know if anybody has heard that phrase before, but essentially what it means is that these systems shouldn't require any human intervention. They shouldn't require anybody to touch them. They shouldn't require anything like that to function. They should just be able to start, do their work, and then ideally go away when they're done. And you can see here, this is a rough infrastructure diagram of what the system looks like today. And those big blocks of servers there are all spot instances. And I think spot instances are really interesting. They're worth a little bit of a digression. I don't know if anybody is familiar with them, but they don't usually exist in traditional data centers because it's essentially Amazon selling you their spare capacity at a greatly reduced cost. It comes with one caveat, though, and that caveat is when you provision that server at this reduced cost, they can take it back anytime they want. And originally, you got no notice, but now you get something like 30 seconds before that server disappears. So what it requires is that you architect the systems in such a way that they're scalable, that they're resilient, that they can accommodate this, server disappearing from underneath of them. But it does allow us to scale. It allows us to keep our costs low. And we started using spot instances in 2011. At that point, there was no tooling. There was nothing provided by Amazon. So this was a case where there was no open source available. There was no commercial tooling available. So we had to build it ourselves. And we built this tool that we called Steward, starting in late 2012. And when Amazon finally released Spot Fleet Management in 2016, we were able to decommission Steward and make it one of those inactive 68 projects in GitHub. And that's a great story for us because we were able to build it, we got great use out of it, but I love being able to turn off projects and let Amazon handle the things that they're good at so that we can focus more of our energy on the things that are core for us. So again, a lot of infrastructure, a lot of regions. There are these risky spot instances that might disappear out from under us. How do we make sure that we're actually delivering on what we say we do for our customers? And the answer to that is process control. We've had this maniacal focus on process, going all the way back from whiteboards in the office up to these automated systems that we have today. And this screen that you see here is actually something that we have in our office so that every employee, every visitor, everybody can see how the system is performing right now. And these kinds of things, surfacing the high-level performance, helps keep everybody accountable and helps make sure that if there are issues that we can resolve them proactively. And I think it is these systems that have helped us to maintain these levels of reliability. The things that get tracked get worked on. So I've taken you on a little bit of a journey from 2011 to today, and I wanted to look ahead just a little bit. We launched at a startup competition in 2011, and for the last several years, or for the first several years that I was involved with CodeGuard, I would have absolutely called us a startup. But in 2019, it's not the case anymore. We have this mature system, this stable system. We have these rich APIs that our partners are using. And we've really focused in the last several months and, well, really, last couple of years, making it easy for new partners to get on board. That was a lot of investments in our APIs, but also in the process. We can provision new hosting partner accounts in under an hour. And we're really ready for more scale. We've architected the systems in such a way that we're ready to grow. We've grown tremendously in the past couple of years, and there's no reason that we couldn't have, take our 300,000 customers today into 3 million tomorrow without much changing besides our Amazon bill. That's about all I wanted to say about this. If there are questions, I'd be happy to speak with you afterwards. Thank you.